Okay, hello and welcome to our webinar on table extraction for data scientists. My name is Alberto. I work on the Visual NLP team at John Snow Labs. Today, we are going to be touching briefly on an introduction to Visual NLP, to main features of the product, the table processing problem, the table extraction problem. We're going to see some examples. We're going to see a general architecture for the pipelines, different components, cell detection, table detection, OCR. We're going to see some examples in code as well. Then we're going to discuss an alternative approach that is visual question answering. So this is going to be an alternative way of handling the tables. And we're going to see some examples as well. Then we're going to explain super briefly the next steps for this feature in Visual NLP. And then we're going to be taking some questions from the audience. Okay. Okay, this is just a super brief introduction to the Visual NLP product. Just the architecture for you to have an idea how this is organized. At the top, we have Apache Spark, on which we rely for data distribution and parallel processing. And on the top, we have the Visual NLP library itself. Right, the main abstraction for Apache Spark is the RDD and the data frame. That is like the entry point for you to access your cluster and to distribute your data. Then on the Visual NLP side, we have like a layer in pink there of data ingestion. We support formats, like PowerPoint, Microsoft Word, and also a different version of digital and scan PDFs, images. Then we have some image pre-processing, just to make the OCR better, like denoising, skew correction, and things like that. Then we have like more higher level features, the new multimodal family of features, like visual document classification, visual document NER, visual question answering, and the one that we are discussing today, of course, table detection and recognition. Okay, so back to the topic of today, table extraction, right? The main idea is that we are presented with a table, right? And that is data in a specific structure, right? That we want to recover. We want to recover the different relations between each piece of text. And also we don't want to destroy information, like, for example, all the text that belongs to the same cell, we want to keep it together, right? And at the end, we want to obtain a representation like this with as much information as possible, about the data and the relations between those data, right? So this is kind of a complex process. Many different steps are involved. And basically, the idea and the approach that we follow at Visual NLP is that we want to build our pipelines out of interchangeable parts, right? So you have like different options, for your data ingestion. You can do PDF to image, you can do binary to image, you can jump directly, from a digital PDF into representation using PDF to HOCR. Then, of course, you need to identify the tables within the documents, right? Because it's, of course, cheaper, if you just spend computing power on the sections that you care about, right? Then you have the OCR part, right? For the cases in which, for example, you're dealing with digital images, with scanned documents. And for that, you also have like a number of elements from which you can choose from, right? You can have like an entire, end-to-end like text detection and OCR, like here in image to HOCR. You can have like an independent text detection section, right? Followed by an OCR stage. And of course, each of these pieces here comes with a different set of options. For example, you can pick a handwritten OCR model, or you can choose a large model or a super tiny, small and fast model if you don't care that much, about accuracy. And of course, you have like different cell detectors, you know, with different accuracies, with different computational cost, right? So yeah, I mean, there are of course some predefined recipes that we're going to see. So you can directly download an entire pipeline with everything already selected for you. But you know, it's always a good idea to be able, you know, to define exactly what type of pipeline you want to build, right? And we're going to see examples, of course, on how to do it. Following, there are some metrics for each of these stages that I'm not gonna spend that much time on this. We can get back to this. We are updating these metrics all the time. We are adding models all the time. So this is something that is changing basically. But yeah, the information is here. So we always promise to deliver state of the art for every model that we ship. So yeah, the information is here. You can come here and check it. So with that said, I think it's a good time for us to jump into some examples. Everything that I'm going to be showing today is coming from this repository. This is the Spark OCR workshop repository, and the folder is webinars. And so, yeah, all the resources, all the notebooks, all the slides, some sample images that I am going to be relying on. Everything is here, right? So it's a good idea to actually remember Spark OCR workshop, you know, this part, and then you can just now find your way into this folder once you hit the repo on GitHub. Okay. So our first example today is going to be related to table extraction. And yeah, we're going to see like first a super simple way of actually running these. I wouldn't call this a one-liner, but it's like a few liners probably, because there's some boilerplate code for importing classes and initializing the library. So by the way, this cell here is for you to be able to upload your license, and that you can request. I think it's going to be shipped, you know, before it has been shipped before this webinar in a JSON file. So if you go here to this button here and you press here, you're going to open the notebook in Colab, and you can start uploading the licenses, and basically you have everything you need to run this on Colab. Okay. So with that said, let's jump into the code. This is just for starting the Spark environment, and yeah, it's just a number of imports and configuration. We typically do this for every example, so I'm just gonna skip it. And yeah, this is the example that I was talking about. This is the few lines table extraction. In order to run this, to show like the first example, we have this example for a table. You know, this is a sample table that is kind of an easy table. And what we're doing here is we're just loading the data into a data frame, and we are just calling this display images function just to show, you know, the image on the notebook, right? And to take a look at it. Okay. Well, now let's jump into the actual table extraction code, right? What we're doing here is we are calling a pre-trained pipeline, and what this means is that you're basically downloading a model from the Models Hub. And I'm going to explain a bit more about the Models Hub and what things you can find there, why it is important, and how to navigate it. Actually, it's a pretty simple user. You know, it's a super simple web page in which you can find all our models, and you can find like information and, you know, all type of examples and data. Okay, I'm going to touch on that later. But yeah, the idea is super simple. You just download the pipeline from the Models Hub. You apply the pipeline on the image that you have just loaded into memory, and then you call this utility function that is display tables, and that's gonna render a structured representation, for the table. This time using HTML because we are in a browser, because we are in Jupyter, but there are other things, other formats that you can work with if you need, right? If you need it. Okay, this is, for the super simple predefined recipe, for extracting tables, and it works pretty decently, right? And it's super, super fast. I'm not running the examples here because of the time. It's like we have a lot of things to cover and the time is kind of short, but yeah, you're gonna notice that if you run this yourself, this is a super fast pipeline, right? Here I'm just plotting the schema for the results, right? Because this is a data frame. The result, of course, is a data frame, and it comes with a number of things, right? In case you actually wanted to make use of it, right? It's like the table index, for example, is the index of the table within the page, right? And then you have like the area where the table was located and things like that, right? That probably it's useful if you want to build some different application on top of this data, right? So I'm playing with the data a bit, right? I'm calling collect on the data frame, so I'm bringing everything into the driver, all the the data from the data frame. I'm bringing it to the driver so I can work with the data locally. Right? I'm just taking the tables, that is, a Python data structure. I'm just running 2 for loops for iterating in rows and for iterating through cells, and I'm just plotting it in something that tries to resemble a CSV, a comma separated value file. It is not that good. I'm going to show you how to do it properly, mainly because sometimes you need to apply quotes when the text comes with commas, and the library, the Visual NLP library can handle all that pretty well. So I'm going to explain it later how to actually do it within the library itself, right? Okay, so this is, let's take a look at the structure for the pipeline that we just ran. So first we have the binary to image, that was like just to turn the image into something that we can work with. Then we have the image to HSCR, that is rendering coordinates for the text. We have a cell detector, and last but not least, we have HOCR to text table, that is the piece that is putting all the elements together, so you can actually see the table rendered in different formats. Okay, these are like just 4 stages, and as I mentioned, you can actually pick different things and put different pieces to build the pipeline, right? So in order to exemplify that, we're going to see a more complex example. And this is like something that resembles more like a real life use case, right? In which you actually have a document, and the table is somewhere in the document, and you actually want to separate the table, from the rest of the document, and you want to extract only the table, right? So we have a new pipeline for that. We use image table detector. I'm trying to select it. Yeah, it's working. Okay. And the image table detector is gonna do exactly that. It's gonna just crop the table, the interesting region, and then the image split region is gonna take the region information, and it's actually gonna create a new image, with only the table, right? And the code here is just writing that cropped image into disk, right? And that image is included here in the code for these examples, right? And you can see that the table is being cropped. They are at the table images folder, right? That is the one that we passed here at the end, right? So at this point we have, of course, this is everything is just with a toy example. We want to actually be able to debug this and to investigate and see what's happening, in the algorithm. But when you do this at scale, of course, you just run this over hundreds, thousands of files and pages, maybe millions. And yeah, this all happens, under the hood, right? Once you assemble, all the stages into a single pipeline, right? So these raw regions here, again, is just, for us to be able to render into the browser, the table, how we detected it. If you can see, if you have good eyes, here it says, there's a label that says table confidence score, right? It's just that, okay? And well, once we have that, it's like we can also continue, with the rest of the pipeline, and we can, of course, convert this to HOCR, that is a text plus coordinate representation. We have region cell detector that is, of course, going to detect cells. Again, another image raw regions, and then HOCR to text tables to put everything together. The pipeline, that one is something that you can apply, to a large collection of documents. And in this case, we are just, applying it to the image that we just cropped, right? And yeah, this is actually the actual line in which the transformation is being applied, right? Okay, we show the cells, right? How the cells were detected, and we display the recognized table, right? Which in this case, we are using, again, the display tables function. That function is going to be rendering HTML, and the browser is going to be able to show that. Okay. Well, that was like a more composable, and more complex pipeline, that is going to be useful for handling real life situations. Okay. And as I promised before, we have here the code that explains how to actually obtain a CSV out of the pipeline itself, right? And in order for you to do that, is like you have to go back to the HOCR to table transformer and set this setting, table output format, I want CSV, right? And once you apply the transformation again, as we're doing here, you're going to be able to work with the result, right? And the result is going to be a CSV, okay? What we're doing here is we're just taking, that single element that is in the data frame, and we are sending it to disk. And I'm here just using a bash command, right, just to plot it. And you see that it actually did a good job regarding the commas and adding quotes, to the cells that contain commas, and so on. Okay. So yeah, this is approach number one for table extraction. Basically, we were able to convert an unstructured representation into something that has a well-defined structure, right? But there's still, another alternative for handling this problem, that is basically using visual question answering. So the main idea and the main takeaway is that many times you don't want to convert the entire thing, you don't want to convert the entire table. You just want to extract some insights, right, that you can express as questions, right, over the image. Mm-hmm. So that's why we introduced the task of document visual question answering, that is basically answering questions about a document when the visual structure is important to answer that question. So for example, here, let's jump to an example related to a table. What is the deficiency level of hemoglobin in blood? For example, let's try to make it bigger, like this. So you have to actually make sure that this value, 12 or less than 12, is related to deficiency and is related to hemoglobin, right? So you can actually answer, lower than 12, right? You actually need to understand the table, okay? That's the main idea. And before we see, one example of this, something that you should keep in mind is that this type of task is an extractive task, right? That means that anything that the model is going to return is coming from the document, right? So you cannot ask things like how many rows you have in this table, 4. No, that's not present in the document. The model is not supposed to answer that well. But for all the other things, that are mentioned in the table, for example, you can definitely ask questions about that, okay? And that's the nice thing about it, right? And if you want to check, there's some explanation about the architectures, but I think the time only allows, for us to see some examples, right, for this. So yeah, again, it's like the same setup, the same Spark initialization, but this time we are using a different pipeline. We load an image, and you can, of course, you can apply, table detection. So you only apply, the model on the image or the section of the image that you really care about, right? But at this point in this example, we are just starting with an image containing a table, right? So yeah, it's like this is simple, right? This is the pipeline. We only have two things in the pipeline: the binary to image, right, and the visual question answering. Of course, as we did for the other models, you have to pick a checkpoint here, right? A pre-trained one from the models have. And the next thing we do is we add some questions, for this image. So things like what is the estimated population in poverty in Lawrence? What is the population of Stoddard? What is the page number of the document? What is the date in the document? How many records did Michael Jackson sell? No, this is not an error. This is actually on purpose. I'm gonna explain why we have this unrelated question, right? But yeah, this is connected with confidence scores, right? Okay, so once we have everything in place, all our questions, we have a model, we have the pipeline, we can call the pipeline, right? And the output of the pipeline is something that is called a BQA output, meaning it's like a structure containing questions, answers, and confidence scores if you actually ask for them, right? There's a setting. But yeah, I think by default, you get the confidence scores. And if we check the answers, it's like, for example, for the first, what is the estimated population in poverty in Lawrence? Population in poverty in Lawrence, 22.5. Okay. Then you have other questions like what's the population of Stoddard, for example, population of Stoddard 26K 800, and you have it here. Then the page number, remember, then the date mentioned on the document, it was January 1970. Yeah. Okay, but then what happened with the question about the records of Michael Jackson, right? You get a number that is, of course, absolutely wrong because that information is not contained in the image. The image has nothing to do with that, but you get a low confidence score for that, right? That's the result. Okay, so that means is what it means is that you can actually just apply questions, on your images, on your tables, right? And if the table, happens to be unrelated to the question that you want to ask, you can use the confidence score, just to filter what the responses and to actually be able to tell whether the response is a good response or not. Okay. And well, we have like another example here. Also, with a list of something that seems to be like a list of materials, right? And we have two questions here. And yeah, if you see, I think it's like a similar example in which you ask something that is not present in the document, like what is the date mentioned in the document. We don't have a date here, right? But we do have total field cost, right? It's like 1,800,000 something. So you get like the right answer, for the first question, for the total field costs, and a good confidence score. But when it comes, to the date, which is not mentioned, you get some answer, of course, but the confidence score is low. Okay. So this is like another way of approaching the same problem, just from a practical point of view, a practical perspective, just to have like an additional tool. for you to tackle this. Okay, I'm gonna just give a brief summary. We covered, table extraction basics, best practices. We have seen like two pipelines, one simple and another more complex, some practical problems, some solutions. We also explore super briefly document visual question answering as an alternative to extracting the entire table. And of course, we have discussed a number of examples. Just touching a bit on the next steps for this feature, in the Visual NLP product, we are all the time adding new models, right? We care a lot about the metrics. We add new models all the time. And we're also going to be adding in the future some new formats for the output in the tables, right? So we are considering JSON and XML and some others, just to make your life easier. So you don't have to actually do it yourself. At this point, we only support CSV, but more formats are coming. Also, we want to integrate with a product that is called NLP Lab. So you can actually train your own models, and if you have like super complicated formats, some complex rendering with borders, without borders, with a mix, with shaded background, whatever, you can actually train a new model to handle that if you want to get the most accuracy. And I think this is it. If you want to try it yourself, I think you can ask for a trial, or I think you are going to be receiving a trial license for a number of days. I think it was sent already. Yeah, so now we have some time for taking some questions.
Okay, we have time for a few questions. Alberto is here to answer them. We actually have one already, which is from Angela. Angela is asking to you, Alberto, what is the duration of the trial?
Okay. I was moving things around here, sorry. Yes, regarding the duration of the trial, I think probably it depends on the project, but you can contact NS at johnsnowlabs.com. I think one of my colleagues already dropped the email there in the chat. So yeah, probably you can contact NS directly, and he's gonna be able to explain. Okay, so there are a number of other questions. Okay.
Okay, and then next question we have, are the JSL library and related models available for learning purposes for free?
Yeah, I think that also falls under the same question of the trial licenses, and I also recommend to go and talk to MS. But in general, I think you can use a trial license for learning, definitely.
Another one is, does Doc VQA answer questions about graphics/visualizations, not just tables?
Yes, in general, you can use Doc VQA to answer any question, in which the visual context is relevant. For example, any other type of chart, some forms, any other type of visual structure in which, making sense of the layout and the chart is important to answer, you can use .vqa for that.
And we had a couple questions about how long the trial period is. If you would like, you can email Ines, which is ENES, at johnsnowlabs.com to get a little more information about the trial period. And then we have another question Will it run on Databricks clusters?
So it's if the Databricks clusters is a supported platform. Is that the question?
Yeah, that's what the question looks like. It was from Jose. Jose, if you're happy to send over a more, clarification, we'd be happy to get to your question. But why don't we move on to the next one while Jose clarifies if you're comfortable.
Yeah, it definitely works on Databricks. Yeah, it definitely works on Databricks. We also support the GPUs on Databricks. Yeah, I love Databricks. Almost, I mean, we are partners with Databricks. All our libraries run on Databricks. So yeah, definitely.
Another question is, how do your models compare with open source tools like Tabula and Camelot Python?
Okay, yeah, I don't know about the Camelot, but we have tried and evaluated Tabula. Another one is, I think it's called Unstructured. And yeah, it's like we had the models are more accurate in general, and also the setup is way more user friendly, meaning that it took us, several days, for us to set up these open source models, open source tools and models, and we're talking about senior people, with years of maybe more than 20 years of Python and other languages, super experienced people, and it took a lot of effort to actually get all these things working, and the results were not that great. And also we provide other things like the scalability, the security for the library. It's like most likely if you go and install one of these open source tools, it's good for experimentation, definitely, but then your security team at your company is gonna complain, because all the scans, are gonna turn to red when you want to do a deploy. So it's also, there are several factors that you have to consider. Yeah. Then we have another one. How does OCR compare to other alternative offerings? I'm taking that responsibility from you. I'm reading the questions. Yeah, it's we have some benchmarks that we did against some cloud providers in the past. Basically, a lot of people is choosing us, or has been choosing us in the past because when they compare to cloud providers, we deliver similar or higher accuracy, and we are cheaper, right? Because when we offer you a license for a cluster, you can basically scale the cluster as much as you want, right? So we don't care if you do like, I don't know, 1,000 words or 1 million words or whatever. I mean, if you want to scale up your cluster and recognize more text, you're welcome to do it. But the other offerings are the cloud providers. They're going to charge you, I think it's by the page. I don't remember right now. But a lot of people used to select us because of that. And then in the last release, we introduced a speed up of almost 6 or 10 times. So we computed a metric on Databricks, and I think it was 10 times faster for the same price, for the same number of Databricks units, the DBUs, that's the unit they use of Databricks to measure. So it was almost 10 and 12 times faster, and yeah, for the same money, right? How good is it with tables with multi-row headers? Yeah, I think this is related to headers and spawning. The vertical headers and horizontal headers is like spawning rows and spawning columns, basically headers, right? Yeah, that's something that is I believe it is not working perfectly at this point. We are doing a new release, and we're gonna add the ability to actually handle that better. But yeah, it's like headers are always difficult. But yeah, we are actually improving all the models and the pipeline in general. The languages, I think, I don't remember how many languages, human languages. I guess it's about German, French, and things like that. I don't remember out of the top of my head, but there are a lot of languages that you can use, right? You just need, I mean, when you assemble the pipeline and you want to do it yourself, you just need to pick the right OCR and keep all the remaining stages the same. That's enough, for you to actually support new language for a table extraction. Can you explain the visual BQA model? What is it based on? Yeah, in general, we don't use only one architecture. I think probably the idea is that the question is related to the architecture we're using. These days, most of them, are the ones that we use the most, are in encoder decoder. We used to have like some other architectures, which depended on a separate OCR. For example, we have those, but we are not using them anymore. We have things like donut, fix to struct, and some customized versions, of these models. Those are the ones that I remember now. Can you please repeat the name of the train your own model app you mentioned in the last slide? I think that must be the NLP lab. Basically, we have a tool that is free, right? That you can use for doing data labeling. So you can, I think you can even use it on AWS Market instance. So I mean, there's no setup. You just need to pay AWS for the infrastructure. We don't charge you anything. And with that tool, you can actually train and create, models from your own data. And yeah, I think we are integrating, the ability to actually train new table recognition models in the next releases. I don't know if this is going to be the next one or the one after next, but yeah, that's it. Yeah, it's the name. Back to the question. The name is NLP Lab, right? So do you guys have a model that allows the retrieving of medical information from medical graph in scientific research posters? I think probably the folks at the NLP team do have something like that. I think I don't remember exactly the name, but if you search the documentation and the repo, the Spark NLP workshop repo, remember the one I shared is Spark OCR workshop. Okay, there's a similar repo that's called Spark NLP workshop, and they have some pipelines that they use to create graphs. And I'm at the risk of being wrong. I think the graph database they used was not for J. I don't remember this exactly. Okay. So now there's a question from Angela Patterson. I've worked with one OCR extraction product that had difficulties accurately extracting tabular data when the text was positioned extremely close to a grid line of a table set. Is that a challenge to this package? I don't exactly, I mean, there are different layouts, and having a single model to handle all the layouts is difficult. I don't know exactly this case, if this is problematic or not. I remember it was kind of challenging to handle, for example, the borderless tables to actually identify what was in a cell and what was not in a cell. But yeah, I think that Angela, probably you need to try, you need to give it a try, because I don't remember exactly that specific use case. How do you upload files? Probably this is related to the setup of the demos. We are using Colab for the setup of the demos. So Colab has a folder that is called content, I guess. So there you just create a folder called data, and you're going to see that the repo has also a data folder. So you just take all the files, you know, from the repo, from the GitHub repo, and you just replicate all the same files there in Colab, right? Under content/data, and you should be good to go. All the notebooks are going to run, all the files are going to be found, and everything's going to be nice. You already showed that the model can detect the border tables. What about the borderless tables? Is the model able to detect the borderless tables correctly? And if so, do we need to use any specific model or features? Yeah, if you want to work with borderless tables, you need to make sure that you include the cell detector in the pipeline, because the stages that you place on a pipeline have some flexibility, and you can actually skip the cell detector, but the results are not going to be good, especially in borderless tables. Okay. DocDQA can be used combined with streaming for something like linked real-time image querying. Yeah, you can use streaming with any of the pipelines that we showed in the presentation. Almost with anything that we put on the repo, on the workshop repo, you can do streaming. So real-time image querying, yes, probably yes. Is the file type of picture? Probably this is a question related to the format of the input files. I think we have used images, you know, for all the examples, but you can go with PDFs, you can go with Microsoft Word documents. You just need to include the proper conversion stage, you know, before the rest of the elements of your pipeline. So in the case of PDF, you have a PDF to image, you know, and for other cases, you have similar annotators. Okay. In one of the examples, you show us how the model identifies the tables correctly. How does the model identify? The example has like two tables I can see. One has the table with data, and another table has like a graph, like a probability curve. I don't understand this one. Okay, let's keep it because can this be accessed from iOS app for processing images uploaded from a user? Probably you cannot run this on an iOS app. Have you had success extracting references to sections within a document? Example, if a cell reference sections 4.1.3 or references to other documents, how have that setting? This is more like an NLP type of problem, right? In which you actually want to identify that portion of the text in which you are making a reference, you know, to some other place of the document. Probably with some type of name entity recognition model, you can do this. Probably this is doable, yeah. But this is not the goal of the Visual NLP package itself, right? Everybody can hear me, right? Because there was one guy who said you're mute. So Tyler, can you hear me?
Yep, sorry, my mic wasn't unmuting. I think that's actually all the questions we have. We haven't gotten one in a few minutes.
Yeah.
So if you're comfortable with ending things, everyone, thank you so much for joining us. Alberta, do you have any final words for the audience before we sign off?
No, thank you for your attention. I hope the provided answers were good enough. And yeah, just contact us if you have more questions. You know, we are happy to continue the conversation on email or Slack or by any other means.
Great. Well, thank you everyone for taking the time to meet with us today, and we hope to see you on the next one. Enjoy the rest of your days.
Bye-bye.